just looks like a regular flushing toilet, but it is anything but.
Yep, that's right. So it flushes.
Good morning. So today we are going to finish the truth conditional meanings of quantified sentences. And that will pretty much lead us to the end of the truth conditional meaning part of the course. And then for the remainder of the 2 weeks, we're going to talk about some other stuff in semantics. We're still going to do a little bit of logic translations. We're going to talk about how to do time on Friday. But for the most part, starting next Tuesday, it's going to be more so like other linguistics courses where it's just a little bit more talking and showing some issues and a lot less mathematical and a lot less technical. Um, so yeah, today and Friday are like the last day of full-on mathematical technical stuff. Let me just get rid of those beeping sounds. You don't have to hear those. I'll write this in an announcement too, but just as a reminder, and let me show you. I'm sure if you've looked at Canvas, you might have seen this. So one thing, as a reminder, the assignment 5 is due on Friday, but what I've done for assignment 6, and I'll show you on the syllabus. So before I had assignment 6 due on August 3rd, which gave you like a week and a half for everything, and then test 3 was on the Friday. It's possible to finish all of the questions in assignment 6 by August 3rd. So if you're not super busy during this time, and I realize that's a stupid thing to say because of course you're probably super busy during the time it's the end of the semester, but if you're someone taking 1 or 2 courses, or you have a lot of effort to put into this course and you can finish everything by August 3rd, then by all means it's definitely doable. But if you're someone who needs more time for the understanding and extension questions, I'm letting you take until after test 3. So after the classes are officially over, to submit them on August 10th. So giving you a week between learning and reinforcement. So stuff that is like necessary to help you with the test on Friday, and then the extension stuff that's after. So on the grades page, these are going to be separate entries. Learning and reinforcement on the 3rd for 4.5 points, and understanding and extension on the 10th for 5.5 points. Just to make this last week and a bit a little bit lighter on you. So everything still has to be done, but just to spread that out. Again, like I say, the test in the course isn't supposed to be like the final pinnacle of the most difficult stuff in the course. The questions at the end of assignment 6 are probably some of the most challenging questions in the entire course. So I don't want you rushing that in a week and a half, 3 days before that last test. So if you need an extra few days after, I'll give those to you.
If we could finish both learning and reinforcement and understanding and extension, can we upload our assignments to the learning and reinforcement slot?
Yeah, sure. Yeah, I mean, I'll just take a look at your submission and I'll put the grade into each of the respective categories. The nice thing is that there's only like a little under 40 of all of you, so if you make however you submit your stuff, it's really easy for me to figure out. It's not like there's 200 of you and I have to spend so much time matching your names. So as long as I get your work, I'll be able to figure it out. So I'll put that out in an announcement soon. Assignment 6 is also up, by the way. So if you want some practice with the practice for the trees that you're seeing now are on the lecture page for truth conditional meaning of quantified sentences. But the learning and reinforcement questions related to this stuff are also available on assignment 6 if you do want to do those. Yeah, so those are available now, and that's just what I wanted to start this lecture with. So to start, we're going to just quickly show this slide. So this is what we finished up with last class, and then take a look at the other tree and just point out the differences. And then we'll take a look at pronouns, and that'll be it. So this might be a shorter week than others. So we'll reserve the last hour or so for questions. And if anyone has questions about the assignment or appointments with me and you're free in that last hour, we can just do it then. So I guess I should start out and say it's been a few days since we did this. Has anyone looked at this, and does anyone have any questions about the trees, or have you made any progress with or attempted any other problems? I guess, sorry. You haven't had any problems with these trees yet, but has anyone looked at this tree and have any questions about it? Okay, so in that case, I'll tell you what I want to focus on in this tree to compare the two differences. The two differences in the scope ambiguous tree are about the quantifier order. So in our case, where this is reflected is in the binding order. And also like how the quantifiers appear, like if for some D and if for all D prime. So that'll change in our spell out. But so as we can see here, because we did the exists a y first in this case, so this is some skill. We did this first substitution where g of t2 is equal to d. So the first thing that we saw in our tree was that instead of x knows g of t2, sorry, my face is in the way. Let's just get rid of that. X knows g of t2, we replace that with x knows d first. And then as we look up at the top row, we still see that substitution, but d prime was made later. So that g of t1 was replaced with d prime in that second step up top. So basically the big difference between their two trees for scope ambiguous sentences is just going to be the order in which these are bound. So the order in which g of t1 and g of t2 are replaced in our final spell out. We won't go through the tree in such fine detail, but we'll still go through each of the nodes. So this was for all x exists a y. So every actor, then some skill. So now we're going to flip the order. So this slide is going to be some skill up top and every actor on the bottom. So this is exists a y for all x. And we'll start with the same thing that we started with before. So exactly the same starting node here. T1 knows T2, it's true if G of T1 knows G of T2. So in this case, we're going to find that G of T1 will be substituted first because this is the, for all, the universal. And then G of T2, our existential, will be bound second. So we can see that in the movement, NP1 is here, which corresponds to T1. And then NP2 has been moved higher, which corresponds to T2. So
Wait, did you state the difference is the order in which what was bound again?
in the order in which our traces will be bound.
Okay, thank you.
So first we're going to do every actor. So we're starting with essentially the translation here, knows X, Y. And what we're doing is we're bringing the phrase every actor into it. So what we're doing at this node is we're binding the X. So we're saying for all X, if X is an actor, then knows X, Y. So basically we're doing this bit of binding here. We're binding our X's. So that's what's happening at this step. So in our rule, we're just applying our rule for every. So if for all D in our universe, if D is in our noun, so if D is an actor, then our sentence, so T1 knows T2, is true, but we're doing some binding here. We're saying that G of T1 is now pointing to D. So we're binding T1 with D. So when we spell this out, we're just saying for all D in our universe, if D is an actor, so if D is in that set, then, well, if we take a look here, our G of T1 is now being replaced by D. So if we just look at those two translational differences, we're saying then D is in the set of X, such that X knows G of T2. And this is also reflected in that predicate down here, knows XY, where that first position is now bound. So this is like saying D is an actor and D knows G of T2. So maybe it's helpful if I just write that right there. So it's sort of like saying it for all D. If D is an actor, then D knows G of T2. So that's that first step. Now, when we go up to our second step, I'll leave that on screen as much as I can there. I'm just going to rewrite the predicate translation for what we have now. So that's actor X arrow knows XY. So what we're doing in this next step is we're bringing some skill into the equation. So we're doing the part where we say exists a Y such that Y is a skill, and for all X, if X is an actor, then X knows Y. So what's going to happen in this case is we're essentially binding all of our Y's in this case. So all of the X's were bound in the previous step, and now we're binding all of our Y's, and now everything will be bound after this step. So we're binding NP2 here. So this is a skill. So if we just spell it out piece by piece, first we apply the rule in the first step. So this says if for some D prime in our universe, so again, we're using D prime here because we've already used D. So you could use E if you want, or any other letter that hasn't been used already, but we've used D prime, so we've used D, so now we're using D prime. So D prime, for some D prime in our universe, D prime is a skill, so it's in the noun, and S2 is true, so sentence below it is true with some binding modifications. So now G of T2 is equal to D prime. So we've had essentially two different assignment function changes to account for our binding. So the intermediate step just shows that there's two occurrences of binding happening. So D prime is replacing D2 and D is replacing T1. So that's just saying that both of the things that happened have happened. So we don't need to include this, but that's just showing both things. And then this final step is just showing everything at once. So I'm trying to remember the colors I've used. So I'll just highlight these. Well, let's take a look here. So if for some D prime in our universe, D prime is a skill, and for all D in our universe, if D is an actor, then D knows D prime. So this will match our predicate logic translation exactly. And if I just put in the D primes and D's from below, we can see how these relate to our translation. So the Y's are like D primes here. So there's the D prime such that D prime is a skill. And for all D, if D is an actor, then D knows D prime. So the actors know the skills. So it's just another convoluted way of writing out our predicate logic translation. At least that's usually how I think about the end result. But if we compare this slide with the previous slide and the final output, again, really what's happening is that we've just sort of flipped the order of the binding and we flipped the way that the value is expressed. So this says if for some D prime, blah, 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 for all D, the other one said if for all D prime, blah, 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 some D. And that's because of the order of the quantifiers in our translations. So any comments or questions about this? Should we use NP2 instead of skill, or is using the predicate? Okay. Okay, so in the rule itself, you can use the NC or you can use the name of the noun itself. Either or. The rule itself says that you should use the common noun. So I mean, if we're being super strict about that, which I know I have been pretty strict about that, but for my own sanity's sake, just seeing which one you've used, you can use the name of the noun. It's just easier to keep track of. And at this point in the course, we know how the pass up rule works in F1. So I'm just going to assume you all know how it works. So whether you use the NC or skill, I know that you know that they're the same thing. And if you don't know that they're the same thing, that the mother and the daughter are the same because they just have one link, congratulations. I'm assuming knowledge. So yeah, we'll just make it easier for us. That's the nice thing, right? When I assume that you know something, then just save us some time. Okay. So that's how we do scope ambiguous sentences. It's just the rules of one quantifier, but we repeat them. And when we repeat them, all we really have to be careful of is, assignment function replacements. Use a different variable if you've already used one. So if you use D, don't use D again. And make sure you're replacing the right variables. So if you're using NP2, so in this case, we're doing NP2, then make sure that we're doing some replacement with T2. If we're replacing NP1, make sure we're doing some replacement with T1. So like those are the two hints. It's like first, make sure you're using a different letter. If you've already used one, and make sure that when you're binding with the right number. If you don't bind the right number, things will not work out properly. And if you use the same variable, you'll get a confused interpretation. You'll get like reflexives when you don't want reflexives. Speaking of reflexives, oh, what a great transition. That was totally unprepared. We can talk about pronouns now. So for some of you, this might be review. For some of you, this is new. I think I talked about this a little bit earlier in the course, but when things are asides, I know that they're not always remembered. So here's a talk about free and bound pronouns. So sometimes this is very syntaxy in its descriptions, but I'm not going to talk about this in a very syntaxy way. We'll just introduce it in terms of meanings. So when you have something that is a free pronoun, it just refers to something in the world that's like not necessarily mentioned in the sentence. So we can see these with indices on our names. So for instance, John I likes her J. So her is someone else in the world. It's not mentioned who her is in the sentence, and her is not John. So it's free because there's no mention of her in the sentence, just someone out in the world. In a sentence like he talked to him, where he is I and him is J, I and J are two different people. They refer to two different things, and neither I nor J are mentioned previously in the sentence. So he is person one and person I, and him is person J. So we'll give this person a mohawk or a cyst or something. So we know they're different. So those are two different people. Bound pronouns are a little bit different. So bound pronouns are bound by something earlier in the sentence. So we see some quantifier words here. So something like every boy loves his mother. And these are indexed. So it is possible to have a sentence, every boy loves his mother, where his is some particular person out there. Like every boy loves, say, James's mother. But we index these with the same letter. So every boy loves his mother. So that way we know they're talking about each individual boy. So this just means that like, so boy one loves mother one. So I'll just use the typical gendered drawing. So that way it's clear. Boy two loves mother two. Boy three loves mother three, and so on. So that's like a bound pronoun reading. So every boy is binding the word his. Here's another one we can do. Some biologists think she is smart. So yeah, she could mean someone else in the world, but in this case, they have the same index. So some biologist I, she, I. So she means that particular biologist. So there's some biologist here. I have a monocle. Maybe they're a cyclops. I don't know. And she thinks she's smart. So if we do want to say that these are different people, so I'll put this up here because it's in the free section. So some biologist thinks she is smart. If we want to say it's free, then we could do something like some biologist I, she, J. So in this case, this she is free because we have I being the biologist and J being someone else. So this would be someone else. So the indices help us figure out if it's free or bound in our cases. Like the brain is doing its own thing. It's choosing its preferred interpretation, but in semantics, we predefine which one we're looking at. Now, to help us do our interpretation, every single pronoun that we look at is going to get a number. And that way we can link it up with our antecedents. So when we say antecedents here, In terms of conditionals, we always mean the thing on the left of the arrow. In syntax, we mean the noun phrase that's giving meaning to the pronoun. So the antecedent of she in B or 16b is some biologist. The antecedent of his in 16a is every boy. So every boy gives meaning to his mother or to his. Some biologist is giving meaning to she. So some biologist is the antecedent.
So the numerical index only applies to bound pronouns?
The numerical index applies to every pronoun. Because we might have something that's like a doctor, right? So maybe this is the beginning of a sentence. A doctor believes that, and then we have she one and she two, and we have a choice. So if we have a doctor two who believes that, and then we pick she one, then she one is some other person that's free. But if we pick she two, that means that she is the doctor, and then it's bound. So all pronouns will get numerical indices, so that way we can figure out if that pronoun is free or bound. Sorry, I deleted that whole thing there, but I just want to get rid of that. Okay, any questions about free and bound pronouns? Okay, one thing that is very important. We have indices on pronouns. We have indices on quantified nouns, especially ones that have undergone movement, and we have indices on traces. So we have numbers on all of these things. And our system treats all of those numbers, so all of the threes, all of the twos, all of the ones, each number goes to one person. So whether you have, say, he1, t1, itself one, all of the ones would pick one individual. They're all bound together. So when you do an assignment function replacement on T1, you're really doing an assignment function replacement on everything with a 1. So if he1, T1 itself 1 is Jack, and you do something like G, let's do Pam prime on T1, then what's happened, let me copy and paste this down here, and let's actually move all of this to the left side of the screen. Then what's actually happened is all of those get changed to Pam. So this will be important for handling things like reflexives, like a girl likes herself. And we'll see how that works in a tree. But this is just an important way that the system works. So you'll notice in this little assignment function here, when we have he1, himself 1, and t1, these all have the same name, Jack prime. When we have she 2, herself 2, and t2, in this case, these are all Yoshiko. When we have she 3, her 3, and t3, these are all Kayla. So the numbers all correspond to the same person. Now, what you'll also notice with this is that sometimes then the pronouns just don't work. So for instance, well, they don't work according to stereotypical genders. So for instance, he and itself typically don't describe Pam. Pam would typically be a woman's name, so you'd hear she or herself or her. Now, this is not really a concern with us. We can use whatever pronoun we want. That's what the system says. So we just pick the pronoun that's most appropriate for our situation. Sort of like we did with predicate logic. When we had that free variable x, we just picked the pronoun that was most appropriate. It's going to be the same with how we do things here. Okay, so I mentioned this because, and I really emphasize this point because this has led to some confusion in the past. So when you substitute a number, such as T1, all of the ones change. Okay, so let's take a look at a sentence with a free pronoun. And what you're going to notice about the free pronoun tree is that there's nothing exciting happening at all. And this is not an exaggeration. There's literally nothing exciting happening here. So with free pronouns, there's no binding. There's no fancy rules happening. Because free pronouns, they're just pronouns standing in for proper names, right? When I say I like her, her is just a person's name, but I'm not specifying the person's name. There's a context. That's it. Context tells you who her is. And it's the same with these sentences. So really the exciting part, so this is the sentence, Natasha likes her. So if we take a look, here's the exciting part of the tree. This is the word her, the object her. So because this is a pronoun, we need to use the assignment function to figure out what the pronoun is. And this is the same thing as the traces. Don't evaluate pronoun until the end because it might get bound. And let me again move this to the side here. So we're going to leave the pronoun in the G of her to form. So the pronoun is her to, so we just apply the assignment function to it. And we're going to leave it as G of her to until the very end of the sentence, unless it gets bound. So as we go up our tree, we just use this pass up rule. So the pronoun is going to be the same as the daughter. The NP above is going to be the same as the daughter, which is G of her to. We have the verb likes on the left here. So this is the pair of x, y, such that x likes y. We've seen like so many times in this course. So when we take a look at the VP, again, we're just doing the same thing that we've already done like a lot of times before. We're taking this object, specifically G of her to. We're saying, okay, we're going to plug it into the object position, and we're going to stop looking for y's. So now we're going to take a look for the set of x, such that x likes G of her to and m. So same as before, but now there's no proper name there. It's just a pronoun. Okay, so now we put in the subject Natasha. So Natasha, same thing as before, Natasha prime, that goes up as the subject. And now the end of the sentence is where things get more interesting. So we're at the final node in the sentence at the very top. So we can apply our rule. It's true if the noun phrase is in the verb phrase. So if Natasha is in the set of x such that x likes G of her to. But this is the final node. So because it's the final node, we can now evaluate what the pronoun is because we know it's going to be free. There's nothing binding it. So we can now replace her with the pronoun. Sorry, we can now replace pronoun with the name. And this is using the same assignment function as before. So This was where ones all went to Jack. This is where twos went to Yoshiko. And this is where threes went to Kayla. So because twos went to Yoshiko, G of her two is Yoshiko. So this is true if Natasha is in the set of X such that X likes Yoshiko. So this is more informative than just saying Natasha, this is true if Natasha likes her, because now we know specifically who her is. So if we want to know when the sentence is true, we have to say, okay, well, does Natasha like Yoshiko? So we know who this is to confirm truth. So I'm not really I'm not really downplaying how unexciting this tree is compared to what we've just been doing with quantifiers. This is basically like what we did in F1 in lecture 6, but we have this little pronoun and assignment function that we couldn't do before. So no matter where the free pronoun is in the sentence, this is how we do free pronouns. So whether it's she likes him or every person likes her and her is some free pronoun, we wait till the very end of the sentence, we see it's not bound, and then we evaluate it. Why did you cross out the Y? Oh, sorry, I was just plugging in the object and then showing that we're not searching for Y anymore. I was just sort of talking through that process, and then I crossed it out during my talk through. That should not be permanently crossed out. Okay, so let's go to a bound pronoun, because bound pronouns are where we're going to have binding, and it's going to look a lot more like what we've been doing with the quantifiers. But remember, so with the bound pronouns, the one rule that's really making this possible is the fact that T2 and her two and she two and it two all point to the same thing. This is that special rule that's making bound pronouns possible. So let's take a look at that in action. Okay, so this is the sentence, a girl hit herself. And I told myself I was going to make this sentence less violent in this semester, and I see I've forgotten to do that. So my apologies for that. But let's take a look at this. So first of all, a girl hit herself. So this is a sentence with a quantified noun phrase in it. So a girl. Now, because we have a girl, we need to do movement. Now, I know the word order is fine. A girl is the subject, so if we just did a girl in place, the word order would look okay, but we do need to do quantifier raising. So we do have this movement here. Now, because we have a girl too already indicated, and this is important because we need to know that herself and girl are talking about the same thing, we need to make sure that we're using the right trace number. So for the sentence, a girl hit herself, sorry if this is a little small, I'll zoom in when we go through the tree, but I am using T2 for this trace, and that's important. We have a girl 2, so I'm using T2 for the trace, and I'm using NP2 when we do movement. Because at this point, the numbers are predefined, and the numbers have meaning. If I don't give you numbers on the quantified noun phrases, you can pick whatever numbers you want. But when we have pronouns involved, the numbers are predefined and they're important. So we have to keep those the same. Okay, so this is a girl hit herself. We did some movement. Let's take a look at the tree. Okay, so herself. This is just a pronoun. And like I said in the last one, we don't know when we're looking from the tree's perspective at the beginning, whether the pronoun is going to be free or bound. So we don't evaluate it until the very end. So we have herself too. So we're going to leave it in the function form, G herself too. So this is going to go up the tree, G herself too. We have this verb hit. So pair X, Y such that X hit Y. We're going to end up with a VP where we end up with a set of X such that X hit G of herself too in M. So this is exactly what we saw in the previous slide. So X such that X hit G of herself too in M. It's just a pronoun going into that object position. And when we go to the sentence, we had some movement from the subject. So the subject moved away. So we have a trace here. So this is going to be G of T2 as a trace. So we're going to treat it just like we did with the quantified sentences. So G of T2 is our subject right now. So our sentence is true if G of T2 is in the set of X such that X hit G of herself too in M. So this looks like everything we've seen before. We have a pronoun as the object and we have a trace as the subject. So we just have two things that we can't evaluate yet. So how do we evaluate these? Well, we're going to do some binding. So you can imagine what's going to happen here. Normally when we do binding, we say something like, okay, G of T2 is equal to D, and then we do one replacement. But what's going to happen, and I'm just going to spell out the rule now. So we'll talk about it when we look at the rule, but let me just illustrate exactly what's going to happen. We are going to do a replacement where we have the assignment function and we do D replacing T2. So this is what's going to happen. Now, because D replaces T2, we're going to have T2 pointing to D. But this also means that everything else with a 2 index is also going to point to D. So herself is also going to point to D. So what's going to happen with our translation at the end is it's going to say this will be true if D, let me use a thinner color, if D is in this set of X such that X hit D in M. So if D hits herself, if D hits D. So both of those things will be bound by the same variable. So that is what is going to happen in our final step. And this is all made possible by the fact that everything with the same number gets changed to the same constant or variable. So let's take a look at this. And let me just get rid of these two D's because those have not been changed yet. Still want to keep this here. So let's put that there. Okay, so we have a girl down here on the left. So we know girl and girl. So now we're doing a girl hit herself. So also let's do the translation here. Exists in X such that X is a girl and X hit herself. So this would be saying that X hit X. So this is our translation for a girl hit herself because X is hitting X. So that same person is hitting that same person. So if we think about our binding here, so for some D in our some D in our universe, D is a girl, and S1, where D replaces T2, is true. So this information over here is what's happening with the binding. So in our final step, in the second step, I'm just pointing out specifically that herself too is being changed here. That's what the extra step is pointing out, just that thing there. And then in the third step, we have our final result. If for some D in our universe, D is in the set of X such that X is a girl, and D is in the set of X such that X hit D in M. So we're just seeing the replacement of the trace and herself too with that same variable. So that's how we can do bound pronouns. Are there any questions about this process?
So for the second line, D is in the set of X, X hit G of herself and D of T2. Why isn't the D slash T2 not on the the superscript, but on like the same line?
So D slash T2, this is just a modification of the function itself. So because the function is not superscripted, the D slash T2 is not superscripted. So
Oh, okay, yeah.
yeah. Can I zoom out if there's no more questions? Yes, I can zoom out. Sorry if it's a little small. Yeah, sorry if these slides are a little small on the screen. Luckily, this will be the very last time that we have such a small slide on the screen, but it's the only way that we can get everything on one page. Otherwise, we get list notation for everything, and as much as list notation is nice to read, it's very hard to learn from a first example. Because then mentally we have to have all of these nodes organized in our head, which is just difficult to visualize. Okay, so because these take quite a bit of time to draw out, I do have some practice exercises here. And I also have them on the lecture page on Canvas here. So these are the same ones. And there is a solution guide to these. So he one likes himself, every student likes himself, and she likes him and she likes him, where she two and she three are different. And I give the same assignment functions. What you'll notice here, and I'll zoom in, is I just say G1 is Jack, and G2 is Yoshiko, and G3 is Kayla. So what I do here when I just give a number is I'm sort of giving a shorthand, and I'm saying that everything with a 1 is Jack. So he won, it won, she won, himself won, him won, T1, all these ones are Jack. It's just a shorthand, so I don't have to define like 8 different versions of pronouns. So we might see that as well. And there's solutions here. So I didn't color code them, but I did write out all the lines for those. So I'll try not to show those on screen in case you want to work on those. So there's one pronoun question on assignment 6, and there's one scope ambiguous sentence on assignment 6. So I recommend doing these for practice and this one for practice as well. On test 3, there will just be one tree for this, one interpretation, And it will likely be something sort of along this line where you have a quantifier and a pronoun in it. Whether the pronoun is free or bound, I'm not sure yet. But the tree on the test just as a very advanced warning. Just one tree that will test something with the pronouns and something with the quantifiers, just so that way you're not doing a ton of work and you're showing me that you've understood like the main points of each part of the lecture. So just because these do take a while to go through and check and the solutions are in Canvas, we won't spend time in lecture doing it, but of course you're always free to check the solutions and ask me questions if you have anything or concerns about those, and office hours as well, it's fine. So that's it as far as the content. I actually was expecting to take a little bit longer than an hour to get through this, but I guess this means it's a rather shorter Tuesday. So that is it for today. We won't move on to tense and time because I haven't completely finished those slides. So I don't want to start something that I haven't completely finished. So instead, if anyone has any questions about the material or the assignments or anything, you're free to stick around for assignment 5 questions or whatever, and I'm happy to answer those. Other than that, enjoy the rest of your day. But that's all I have today. I don't know, it's an hour, but there was a lot of material today. So at 50 minutes, it's still a lot of mental work. So ending an hour early, that's not a problem for me. So yeah, I'll see you all on Friday for tense and time. For assignment 5, 4a, 3 to 5, does the x1, 2, 3 refer to a variable or to the assignment functions? Let me open that up because I forget which question 4 is. 4a, 3 to 5. X1, okay, so X1, X2, X3, and so on. It depends if it's free or bound. If it's bound, then it depends what the quantifier is saying. So like in 3, let me go over to this. So in 3, this is saying there exists a 1 such that BJX1. So B is saying X occurs before Y in the alphabet. So this is saying there is some letter where J occurs before that letter. So this is just acting as a variable. But if this were free, like in this case 1, we don't have anything binding it, then we have to take a look at the assignment function to say what it is, or to see what it is. So there's no quantifier here, so we need to know like what is x2? Well, we take a look up here and we say x2 is s. So sort of just like how our free and bound pronouns work today. If there's a quantifier binding it, we just take a look at the interpretation of the quantifier. If it's free, then we have to take a look at our assignment function and say, well, what does our assignment function say? So in these cases, x2, x3, these are all bound quantifiers. So x2 has the interpretation of every x2, x3 is some x3, and in these ones, it's just some letter x2, x1. And for 5 specifically, I recommend thinking about what this means in English. Thinking about what it means in English is going to be easier than trying out letters. Actually, thinking about 4 and 5 in English rather than testing out letters will be an easier way to solve these. Go over 3. Okay, let me actually bring it up on the PDF so I can write on it. Okay, so this is just an assignment function replacement, but instead of using names and variables, I have used letters and numbers. So in lecture, we did something like okay, maybe like x1 is j prime and g of x2 is p prime. So let's say that's it's Jim and Pam or something. And I could do a replacement and say, okay, I want to take x1 and replace it with, say, d prime. So after that replacement, I could ask myself, what is x2? So after replacing x1 with d prime, what is x2? Well, x2 hasn't changed. x2 is still p prime. So like if I were to draw this out, I would say, well, right now x1 is d prime and x2 is p prime. So this is just like asking, what is this value? So in question A, it's saying after making this replacement, and this replacement, what is the value of 4? And B, after making these same so the replacements are the same in almost all of them except for this last one. And the key for the last one is like, well, which one do you do first and which one do you do last, which was talked about in lecture. So brackets first, inner brackets first, outer brackets last. And then what is the value of each of these? So what is 4 after the replacements? What is 5 after the replacements? What is 6 after the replacements? And what is 7 after the replacements? I'm confused by Q and P. Yeah. I mean, I think the fact that I have spaces between these is also a little bit different, but I tried to put spaces in them just so you could read them a little bit better. I think that might have also made it a little bit tougher, just because it's weird looking, and things are confusing when they look weird. For predicates, can you go over how we did adjectives again? Yeah. Let me add a page to, what did I do? So for adjectives, so if we have something like Charles likes, oh, let's use an actual quantifier. use it at the front just to make it easier. All small animals like Charles. So if we think about this just in terms of how do I want to do this? Okay, just like conceptually, I'll just talk about this conceptually first. We'll talk about the translation. If we think about small animals, and I know small is like a relative term, but you can think of this as like any adjective for now. We have the set of things that are small in the world, relatively small, and the set of things in the world that are animals. So when we say things like all small animals, we're talking about the things that are both small and animals. So like small is a property and animals is a property. So this set right here is the set of things that are small and animals, which in logic can be represented by the things that would be like, say, X is small and X is an animal. So we can sort of treat this as a unit. So when we say something like all small animals like Chris, we could say something like for all X, and then we want to say small animals, right? So we could say if X is a small animal, so if X is small and X is an animal, then X likes Charles. So in other words, we just treat adjectives and the noun that they're associated with as like a bunch of conjunctions. So if we go like one step further and say something like a big round wooden table, this is something that is big, and it's something that's round, and it's something that's wooden, and it's something that's a table. So you can think of it like this is a thing that's a noun, and what other properties does it have? It has the property of being a table, it has the property of being wooden, it has the property of being round, and it has the property of being big. Sort of like saying it's a list of things. It's this and 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 so on.
Another thing with bound, I like understand the scope part, but with bound, if it's like a variable, how to explain it? Like if there's two variables, but the quantifier only has one of them, is it still bound if one of the variables is free, or
Like something like this.
it would be something like if the dog or something had the X and a Y inside, like if something like likes or something, or had two
Oh,
variables inside, yeah.
oh.
Yeah.
So okay, so this is bound. The X's are bound,
But the Y
but the
isn't
Y
bound.
is free.
So would I just say the Y of likes is free, or would I just say the whole thing is free?
So it's the individual terms, so the individual variables that are bound are free. So you'd say that Y in likes is free.
Okay.
Yeah. So this would be a sentence like every dog likes her, where her or him or it or something is some other individual in the universe. It's some free variable.
Yeah, those are just asking about the assignment. I feel like I understand the trees, but I also don't understand. Like in class that makes sense, and then anytime the assignments come, I feel like I know they're like obviously understanding extension, but do you mind going over like a tree with me just to like
Which one would you like?
um I guess whichever one would help me best with the assignment without telling me an answer for the assignment.